Welcome back, Stella. Hope you are doing well. I'm going to go through in the upcoming videos through all the exercises you have been doing and you face difficulties on the integration. Okay, we shall start with this exercise. First of all, I'm very happy because you try as much as possible to try to master the concepts, and it's very important, if you really want to master this integration. It's a very simple topic. If you master the approach, the different approach that I show to you, you have a perfect mastery of this chapter. So there is this exercise you had to do. This exercise, it was after exercises on type 3. Yes, after exercises on type 3, FG and H, there was this extra exercises to practice more. This exercise 4. Let me go to what you did. Naturally, when you look at this, let's go to what you did. Let's go and see what you did. Let me see, where is it starting? Okay, this is the integral. So basically, oh wait, let me see, let me go back. Let me find it. Okay, this is it. So basically what you said is that since the degree, yes, the degree of the numerator is less than the degree of the denominator, so basically you have to express that in partial fraction, and that is very logical because the degree here, if you develop this would, the highest power here will be 2, and the highest power here inside here is 2. The power here being 2, the highest power below here will be 4. You understand? So naturally the degree here is less than the degree here, so you have to express this in partial fraction first. So I will not check your how you express everything in partial fraction. I assume that you have to know how to express everything in partial fraction. This is a repeated linear factor. This is a quadratic factor. So basically, if you are to express it in partial fraction, you have a on the 2 minus x plus b on the 2 minus x square plus, for this other one, we are going to have cx plus d all over x square plus 3. So that's how you're going to express that in partial fraction. Is that okay? So let me check what you did. Let me go back to what you did. Yes. So let's continue. So you basically expressed everything in partial fraction. Let me continue. This is what you did. You were finding the constants, and here is your final result. You had, let me copy that result. You had the function that was given in partial fraction was minus 1 over 2 minus x. Let me write it. So the function that was given, that is, where is it, x plus 1 into 4x minus 1, x plus 1, x plus 1 into 4x minus 1 all over 2 minus x square into x square plus 3. I think that's it. Let me check. Yes, that's it. So after expressing that in partial fraction, you said it was identical to what? You said it was identical to, let me check it, minus 1 on 2 minus x plus 3 on 2 minus x squared. Yes, let me write it. Minus 1 on 2 minus x. I assume that you did well your expression in partial. You did well your procedure to express things in partial fraction. Plus 3 all over 2 minus x squared. And the last term was what is it even? Plus minus x minus 1 all over x squared plus 3. Minus x minus 1. Okay, let me go back. Plus minus x minus 1 all over x squared plus 3. So if I write things, this will be equal to minus 1 all over 2 minus x plus 3 all over 2 minus x square minus, because there is I'll factorize the minus here, minus x plus 1 all over x square plus 3. Basically, to integrate this, we know how to integrate it. This is simply the integral of something of the form 1 all over ax plus b dx. This is a linear function, so you know how to integrate it. It's very simple. For this other one, it's still very simple. It's like you are integrating 1 all over ax plus b all to the n. Is that okay? Dx. So we know how to integrate it. For this other one, I saw you did a small error when you were finding the integral of this. There is no need. I saw you are working. You said, let's go to your working. You said you are working. Where is it even? You said to find this integral, you said that since the degree of minus x minus 1 over x squared plus 1 is less than the degree of the denominator, you express it in partial fraction. No, there's no need of wasting time to express this in partial fraction. This is simply, I'm sure you did that error because you have not yet done this series of exercises. This part, because there is this part. Some integrations of rational functions that will give rise to inverse trigonometric function. Because when I saw your exercises on type 4, I saw that you've passed through these videos and you started understanding how to tackle things. Where are we? So if you do these exercises on integrals of rational functions that give rise to inverse trigonometric function, if you do this, you basically understand how to handle that. It's very simple. Let me go back. Where is it even? Where are we? Okay, we are here. So to do that is very simple. You are not supposed to express this in partial fraction. That was wastage of time. It will not even help you. It's already in partial fraction. It will not help you. What you are supposed to do here is this. You write this x plus 1 all over x squared plus 3 as this will be equals to x all over, because a plus b all over c is the same as a all over c plus b all over c. Is that okay? So this would be the same as x all over x squared plus 3 plus 1 all over x squared plus 3. You see that you can already integrate this using what? Integral of f prime of f of x dx all over f of x. You can already integrate this. You understand? You can also already integrate this using what? Using integration of inverse trigonometric function, because the substitution here would be something in terms of time. You get what I'm saying? So be very careful. Be always be very posed when you are doing things. Don't precipitate yourself. So this will be equals to minus 1 all over 2 minus x plus 3 all over 2 minus x square minus x all over what? X square plus 3 minus 1 all over what? X square plus 3. From there, you can take one by one and integrate. Is that okay? So that was an important point I wanted to mention about this exercise. So basically, you did well the other ones. So that was an important point. So that's all what I had to say about this exercise. For the other ones, you did them well. Now let's move to the next. These exercises to further train yourself. For this first one, this first integral, there is something about you that annoyed me here, and I'm going to talk about it. Let's take for example this first one. Where did you do it? This is where your integral started. Yes, you did well the thing. very well, we notice that it is because it's an integral of the form f prime of x on f of x. When you look at it, you get what I'm saying. Now, reaching at your answer, you're at this level of the answer, how to remove the absolute sign. I was not happy with you. You cannot say that this is equals to this without justifying it. You start saying that since any number square is positive, this is literature. This is not what you are a mathematician. You are not supposed to write things like this. I taught you how to justify, how to know the sign of something. I taught you how to know the sign of something. I taught you how to know the sign. This is a quadratic equation. This is a quadratic equation. I taught you how to know the sign of a quadratic equation. I taught you how to know the sign. You can let me go on a sheet of paper. Let's say after you are to integrate x on the 16x squared plus 25, you are to integrate this. You are to integrate x on the x what? X on the 16x squared plus 25 dx. 16x squared plus 25 dx. After integrating it, you will naturally have ln of the absolute value of 16x squared plus 25 plus our constant of integration. No, you have 1 on 32. Yes, 1 on 32. Where is it even? 1 on 32 here. Okay, how do you remove this absolute value sign? Because in the question, it is asked that you should leave your answer without the absolute value sign. Your problem now, after having the answer in terms of absolute value sign, your problem is to how are you going to remove the absolute value sign? I told you that you have the right to remove the absolute value sign if and only if you can show that what is inside here will always be positive. If you are capable of showing that, if you are capable of showing, if you are capable of showing that what is inside here, that is this 16x squared plus 25, is always positive, then you will be capable of removing this absolute value sign. This is a primitive. There are no boundaries. This means that this integral is valid on a set of real numbers. That is, you have to prove that for every real number, this will always be positive for you to remove the absolute value sign. The whole literature you wrote there, that's not how you are supposed to prove it. I taught you how to prove, how to study the sign of a quadratic expression ax squared plus bx plus c. How to study the sign of a quadratic expression on an interval. I taught you how to do it. I taught you how to do it. So you just need to apply it. You either use that technique or it's very simple to analyze whether this 16x squared plus 60 plus 25 will always be positive on R. It's very simple. You can either pass when we were solving during the holidays, during the how do they call it? During the Christmas holidays, we did inequalities, and I showed you. Go to the exercises we were solving. I showed to you how we study the sign, of a quadratic expression. I showed to you how we do it. Don't just be keeping things. Master things. Don't learn. You forget. Don't learn and forget. Master, learn, try to master something once and for good. Here, to prove that this 16x squared, 16x squared plus 25, to study the sign of this 16x squared plus 25 on R, because it's on R, we have to any primitive will always be valid on the set of real numbers. So to show that, to know the sign of this 16x squared plus 25 on the set of real numbers, this is the first method I can use is this. I know that for all x belonging to the set of real number, a number square, x squared, this is how you are supposed to write things, not that literature you wrote. That literature you wrote has no sense. For all x belonging to the set of real number, I know that x squared is always greater than or equals to 0. It is always greater than or equals to 0 because x can be 0, because 0 is found in the set of real number. 0 is always greater than or equals to 0. Is that okay? If I take minus 1 here and substitute, 1 is always greater than or equals to minus 1 squared will be equals to 1, which is greater than or equals to 0. True. If I take 1 squared is equals to 1, which is greater than or equals to 0. It is true. You get what I'm saying? If I take 0 squared equals to 0, 0 is greater than or equals to 0. It is equal to 0. So it's valid. Now, beside this x squared, what do you have? You have 16. So I'll multiply this inequality by 16. This implies, so let me wipe this. So this implies for all x belonging to the set of real number, 16x squared will be greater than or equals to 16 times 0, which is, this implies 16x squared will be greater than or equals to 0. The inequality sign does not change because we are multiplying by what? A positive number. Now, what do we have to do? We have to add 25 to this 16 plus x squared. This implies for all x belonging to the set of real number, 16 plus x squared plus 25, we add 25 to both sides, will be greater than or equals to 0 plus 25. This implies 16 plus x squared. This implies, that's how you are supposed to show things. This implies for all x belonging to the set of real numbers, 16x squared plus 25 will be greater than or equals to 25. But how is 25? 25 is always strictly greater than 0. So this implies for all x belonging to the set of real number, here you can write, but 25 is always strictly greater than 0. So this implies for all x belonging to the set of real numbers, 16x squared plus 25 is always strictly greater than 0. That is positive. So we basically see that on the set of real numbers, 16x squared plus 25 is always positive. So that's why I can remove this absolute value sign. When you finish integrating, when you reach this level, you first have to do this proof. You first have to do this justification in order to remove this absolute value sign for you to complete the proof that was asked to you. For all x belonging to R, x squared is greater than or equals to 0. You do this up till you reach this level. From there, since 16x squared plus 25 is always strictly since for all x belonging to R, 16x squared plus 25 is always strictly greater than 0. It implies the absolute value of 16x squared plus 25. It must be equals to what? It must be equals to 16x squared plus 25. The absolute value of a positive number is that positive number. This is the definition of absolute value. We recall that the absolute value of f of x is equals to what? F of x if f of x is greater than or equals to 0, or it is equals to what? Minus f of x if f of x is strictly less than 0. Here we have our f of x which is greater than 0, so the absolute value of this is this according to this. That's how we are supposed to justify things. This is the first method. The second method, revise. I gave you exercises. Let me go back to those exercises. What are those exercises even? There are some exercises I gave you. These exercises, we did these exercises. where yes, this exercise is where you were supposed to find the integrals of all of this based on the following conditions that were given to you. We did exercises on this. Revise this, and I can remember that after these exercises during the Christmas holidays, I gave you some important lectures on inequalities and on inequalities. Yes, I gave you some important lectures, how to study the science of functions. Revise that, is very important. That's how you are supposed to justify things, not with the literature you were writing. That's not how you are supposed to do things. So let me go back. For the second method, how are you supposed to prove it? How can you study? So you are supposed to study what? The sign of this on the set of real numbers. Okay, you are supposed to study the sign of this. So studying the sign of 16x squared plus 25 on R. Okay, the first thing you are supposed to do is to determine the first step. Usually what you do is what? When you are dealing with a quadratic expression, you have to determine what? You have to determine the zeros of this quadratic expression. So determining the zeros of 16x squared plus 25. When we determine the zeros, it simply means solving this equals to 0. When determining the zero, let's first find the determinant. The determinant is b squared minus 4ac, which is b squared is 0 squared minus 4 into a 16 times c 25. So 16 times 25, let me calculate. 16 times 25, that's 400, times 4, that will be 1600. Yes, that will be 1600. So you see that the discriminant is equal to minus 1600, which is less than 0. It implies 16x squared plus 25 does not has real roots. Is that okay? It doesn't has real roots. And I told you, when a quadratic equation has no real roots, how do you draw its table of sign? It's very simple. So when a quadratic expression has no real roots, it's very simple to know its table of sign. The step two, we're going to draw the table of signs. Okay, when drawing my table of sign, I first draw my vertical line horizontal. This is x. This, we are studying a sign on R, so this is minus infinity, this is plus infinity. It has no real roots, so we put nothing here. So this is our function here, 16x squared plus 25. Okay, now we need to know its sign here. How do you know the sign of the function here? When a quadratic expression, when a quadratic equation, when it has no real roots, the sign here is the sign of A. The sign of the function on the whole set of real number will be equal to the sign of A. And what is our A? Our A from this quadratic expression, our A is equal to what? 16. What's the sign of A? Plus. So we clearly see from the table of sign that for all x belonging to the set of real number, 16x squared plus 25 is always greater than or equals to 0. From there, you can conclude that the absolute value of 16x squared plus 25 is always strictly greater than 0 because it's strictly greater than 0. Why is it strictly greater than 0? Because it has no real root. That is, there is no number on this set that will always make it 0. Because if there was a number here that makes it 0, it could have been greater than or equals to 0. But there is no number here that makes it 0. So it will be a strictly positive. So this absolute value of this will be equals to 16x squared plus 25. Those are the two methods. So try to revise what I showed you during the Christmas holidays. Try to revise it. Try to revise it. That's how you are supposed to show it. You are not supposed to write the bulk of literature that you were writing. This, where is it even? This literature, that's nonsense. You are supposed to, when you reach this level, you are supposed to put your justification just after, before concluding that the integral of this will be equals to this. I hope everything is clear. So take note of that. So take note of that. That's what you were supposed to do. The same thing, where is the other exercise? The same thing here. That's how you are supposed to justify it here. You're supposed to justify the same thing here before removing the absolute value sign. So take note of that. That's how you're supposed to do things. This, when you calculate the discriminant, if you use any of the two methods, this will always be strictly positive. You understand? So try to use techniques that I showed to you. Don't try to solve things like a mathematician. Don't be doing things as if you were hesitating. You understand? So that's what I had to say about these two exercises. Now for this, you did well these ones. Now for this, you had difficulties in proving this and proving this one. Okay, there are a lot of errors I noticed in your way of doing things when you were solving these things. When you were solving these things, and I'll talk about those little errors. Okay, as I was saying, I saw that you faced difficulties in integrating this. Let me first go to what you did. So the integral of this, you were asked to prove that it gives this. I noticed your main problem is that you don't try to simplify your expression, your primitive expression. Let me tell you what I'm saying. Look at the result you had here. You had that the primitive, the primitive of dx on x into x squared minus 1. You had that this was the answer. Look at something. There is a half here. There is a half at this level. There is a half here. Why do you not combine these two into one thing for you to have a more simpler expression? Why do you not combine it? If you combine it, things will be more simpler. This is what I'm saying. Because I don't first of all know if what you did is correct. But the main thing, when you have such an integral, you basically have to express this in partial fraction, because the degree of the numerator is less than the degree of the denominator. So naturally, to integrate it, you have to express it in partial fraction. Let me copy your answer to explain what I'm saying. So in your answer you had the integral of 1 of dx all over x into x squared minus 1, yes, was equals to, you had minus ln of the absolute value of x plus a half ln of x minus 1 plus a half ln of x plus 1 plus our constant k belonging to r. Let me go back. I think that's exactly, let me check. Wait, this is it. Let me check. Yes, that's exactly what you had. That's exactly what you had. So what I'm saying is this. What I'm saying is this. Instead of working with a long expression like this, there is a half here, there is a half here. You can write this as minus ln of the absolute value of x plus a half into what? Into ln of the absolute value of x minus 1 plus ln of the absolute value of x plus 1 plus the constant k. Let me check things. Let me verify things. Okay, exactly. So from here, you know that ln of a plus ln of b is equals to ln of ab, ln of a times ln of b. So this will become what? This will become a half what? Ln of what? The absolute value of x minus 1 times the absolute value of x plus 1 minus ln of the absolute value of x. But we know that ln of a times b is equals to ln of a is equal, pardon, we know that the absolute value of ab is equals to the absolute value of a times the absolute value of b. This is an important property. So from here, this will give a half ln of what? The absolute value of x minus 1 into x plus 1 minus ln of the absolute value of x. So this will be equals to what? This will be equals to a half ln of what? This times this gives x squared minus 1 minus ln of x. This is a more, don't forget your constant of integration plus k plus k. This is a more simpler expression to work with. You don't see that this is a more simpler expression. This is a more simpler expression. With such an expression, you can easily come out with the answer. You understand what I'm saying? So I'm going to do this exercise. I'm going to do this exercise completely and try to prove it. So I'm going to do it. So what does the exercise say? Let me do it. The exercise says that you are to prove that the integral from 2 to 3 of dx all over x into x squared minus 1 equals to a half ln of 32 on 27. Is that okay? Okay, let me go. When you are asked to prove things, always be very calm in your way of doing things. Always be very posed, very calm in your way of doing things. If you precipitate yourself, you do errors. You do errors that you will not be capable of correcting. So in the next video, I'm going to tackle this exercise. Let me show also a small error you did in this exercise. Let me go to the exercise. Where is it even? A minute. Let's go. Okay, this is the exercise here. This is the exercise what we were supposed to prove. The error you did is, look at something. Why do you break this? Why do you break this into 2 before expressing first of all this in partial fraction, then this again in partial fraction and integrating? That's a wastage of time. That's too much wastage of time. The degree of this top is already less. When you look at the degree, the highest power here is 2. The highest power below here will be something like, will be something like 3. So the degree of the numerator here is already less than the degree of the denominator here. You express the whole of this in partial fraction once, and then you integrate. Do you understand what I mean? What I'm saying? That's a wastage of time. You will express, because to integrate this, you first express this in partial fraction. Wastage of time. To integrate this, you express it in partial fraction. You waste time expressing 2 things in partial fraction during an exam, whereas somebody would just express this one in partial fraction and you will finish the exercise very fast. That's the error you made in this exercise. You understand what I'm saying? And you also, there's also a problem you did here. You don't try to simplify your expression. Where is that exercise again? Wait, let me go to it. Let me go back to it. A minute. Let me go back. Let me go back. Look at your expression. Look at your expression. There are things that can be simplified there, but the thing is that you leave your thing. Your expression is too choked up. There are too much things. How are you going to calculate and simplify things easily? So I'm going to do the correction. I'm going to do the correction of those two exercises. So try to look at these videos and master things very well. So the next video will be a video that will concern the solution of these two exercises. I'll solve them. You get what I'm saying? Okay, so see you in the next video.